Now that we've gone through our interface mechanics with methods, the next thing to learn about is embedding. Embedding is going to be a big part of the language because it's going to help us later on when we're talking about composition. Now, embedding is going to look like a form of object-oriented programming where we get type reuse. And it's going to kind of seem that way right now. One of the things we're going to have to do when we get into software design is kind of twist your brain a little bit and get you out of that frame of mind and get you into a better one. But right now, let's just focus on the mechanics of embedding. So let's start with a very base piece of code here. There's nothing novel going on in this code. It's just helping us set up for understanding embedding. So on line 11, we've got the concrete type user, and that concrete type on line 18 implements a method named notify using pointer semantics. Then on line 25, we have a second concrete type. Its name is admin, and it also has two fields, person and level, and the person field is based on user. Now this is not embedding, okay? This is just a field that's based on a different concrete type that we happen to define with this keyword struct. Now, when it comes to construction in Go, things are tedious because the type has to be very explicit. So you see that we're doing the construction of an admin value using that struct literal form. We're also constructing a user value using that struct literal form because we're going to assign that back to the person field. So we're doing all this construction, and then on line 42, we access the person field from that admin value, executing the notify behavior. All right, nothing novel going on here. We just needed this kind of code set up. And again, this is not embedding. Okay, admin has just got a field named person based on the user type. All right, let's make a couple of changes to this code. And one of the things that I'm going to do right now is maintain our user type. There it is. Also, user is going to maintain its method named notify using that pointer receiver. But admin is going to be changed out. And what we're going to do is pull the person field out of that admin type and just leave the type user. This is embedding. And there's two ways we can look at embedding. We can now say that any value of type admin also has a value of type user embedded inside of it. All right, that's pretty cool. Values of type admin have or contain values of type user. But I think a better way to look at this is to look at this idea of an inner type and an outer type. And what I want you to see is that the outer type admin has embedded inside of it the inner type user. And when we do this inner and outer type relationship, we have what is called inner type promotion. And what inner type promotion says is anything related to the inner type promotes up to the outer type. That means all of the fields and methods associated with the inner type now become part of the outer type. But what's critically important here is that embedding is not creating a subtyping relationship. This does not make admin a user. You cannot pass admin values around like they're user values. In an object-oriented programming language, that type of embedding that we're seeing here creates that like inheritance relationship, and inheritance has always created that subtyping. This is not inheritance. There's no subtyping. Remember, Go is strictly type. Admins are still admins and users are still users. All we're doing here is allowing things associated, fields and methods associated with the user type to promote up to the outer type. So now that we've done that embedding, we can do the construction of that admin value again. One difference now in the construction is to access the inner value, we just use the name of the type. I know it looks like a field and acts like a field, but let's not really look at it as a field. It's really the name of the value that's embedded. We're using the type's name, that's what we have, and we're doing the construction, right, and initialization of that inner value. But this is the cool part on the inner type promotion. We can still access the inner value directly through the type's name. You see that on line 42. But on line 45, we can access the inner type's behavior directly through the outer type without that, without having to indirectly kind of go through the type's name. You can see the output is the same on both calls. And that's that inner type promotion working. So what inner type promotion is doing, it's allowing us to be able to access any of those fields or behaviors. We can have things promote based on accessing it. Now, I know you probably have some questions already. I'm not done yet. I want to show you at least two more code samples, and then your questions should be answered. Let's go and take the same code that we've been working with and let's add an interface. Let's add the notifier interface with one active behavior, notify. Now, what's interesting here is that the user type on line 16 already had the notifier method based on that pointer semantic. But now what we can say is that the user type implements the notifier interface using pointer semantics. User implements the notifier interface. But now, thanks to admin embedding user and thanks to inner type promotion, if you think about it, admin now also implements the notifier interface because that method notify promotes up to the outer type. This is why we don't need subtyping in Go, because it's not about making an admin a user, right? It's not about what this data is. It's always going to be about what the data does. And thanks to inner type promotion, an admin also now knows how to notify thanks to the implementation that got promoted from the inner type user. Great. So we do the construction that you saw before. We add our polymorphic function there on line 54. And this function says, I will accept any concrete piece of data, any value or pointer that implements this behavior. And now on line 49, we can use our pointer semantics by taking the address of the admin value, pass it through. The compiler's OK with it because of the inner type promotion. Remember, user implemented the notify interface using pointer semantics. That means we can share an admin value as well, thanks to the inner type promotion. And the inner types implementation is what gets executed on line 55. Brilliant. Let's throw one more piece of complexity here. Let's go ahead and we'll keep our interface notifier with one active behavior notify. We'll keep our concrete type user implementing the notifier interface using pointer semantics. We'll embed user in admin, but what we'll also do on line 38 now is have admin implement the notifier interface. If you now look at this, we have two implementations of the notifier interface for admin. One from the inner type and one from the outer type. But now that the outer type admin is implementing the notify interface, it overrides the promotion. We don't need the promotion anymore. The admin's implementation always will take precedence. So look at what happens now. We construct that admin value like we were, initializing the inner value user like we have been. But this time, when we pass the address of the admin value into our polymorphic function, it's admin's implementation that's getting executed, not the inner value user's implementation. But because on line 61, because we can still access the inner value directly, there it goes, we didn't lose access to the behavior. So a couple of things that I want to make sure that are clear here. As long as there's no ambiguity, the compiler will never care about these multiple implementations. In other words, promotion doesn't happen automatically. Promotion only happens when you try to access something via that promotion. So a lot of questions that I get in class is, well, Bill, what if admin embedded another type, maybe customer, that also implemented the notify behavior? Would we have a problem? And the answer would be, we would only have a problem if you tried to call notify in a way where the compiler didn't know which one to use. Do I use user? Do I use customer? But in this case, since admin's overwritten it anyway, we really won't have any ambiguity and we won't have any issues. Now, however, in a code review, if I saw this idea of multiple inheritance, the code review would stop because this is not a good design pattern that we want to be using in Go. Now, inner types can have inner types that can have inner types. But if I see that type of pattern, also code reviews are going to stop. These are not patterns that we want to use in Go. Remember, we're looking for readability in Go. We're looking for making things easy to understand, right? Not easy to do. And those types of patterns don't help with understandability. So there it is. That's inner type promotion. And it's again about what a piece of data can do, not based on what a piece of data does. And we're seeing it again here with embedding. And we're going to be leveraging these ideas of embedding in composition very soon.